Hello, this is Keith George, the Educational Technology Specialist with AMSTI, the Alabama Math, Science, and Technology Initiative. And this presentation is an introduction to the digital literacy and computer science standards. The Alabama Digital Literacy and Computer Science standards were developed in 2018 and were the culmination of a year-long effort by a committee of educators from around the state. And in developing the standards, several national references were used, including the AMSTI standards for students. You can see the 7 standards here developed by AMSTI, the International Society for Technology and Education. And those standards are the Empowered Learner, Digital Citizen, Knowledge Constructor, Innovative Designer, Computational Thinker, Creative Communicator, and Global Collaborator. And most educators are familiar with the AMSTI standards as a mechanism for integrating technology into the classroom. So these certainly were one of the reference sources for the course of study committee. Another area that the committee decided to include in the same set of standards was computer science. And so we looked at the K12 Computer Science standards developed by the Computer Science Teachers Association. And these standards are based on 5 core concepts: computing systems, networks and the internet, data and analysis, algorithms and programming, and impacts of computing, along with the 7 core practices or skills that you see listed as well. So this was another reference used by the committee in the development of the Alabama standards. Now, one of the things that came up in the committee early on was the idea that digital literacy and computer science be integrated into a single course of study. There was some discussion about having a separate computer science course of study. The previous course of study that these DLCS standards replaced was simply called the Technology Course of Study. And those standards were quite outdated and quite basic and really didn't leave room for growth for students. So the committee early on decided to include both digital literacy and computer science. That brought up the discussion of which was or was one of the other more important. And what we kind of settled on is that they both are equally important, just at different levels of focus as you move along the grade. So if you see on the vertical axes of this graph, this chart, the level of instructional focus, in kindergarten, it's very high with digital literacy, although you can see in the purple there, the computer science is included even as low as kindergarten. And as the student progresses through the grades, digital literacy doesn't become less important, but there's less focus on it as the focus on computer science does increase. So as you can see, across all grade levels, both digital literacy and computer science are a part of the focus. There's just a change in the degrees. And of course, we have the definitions here of digital literacy: the ability to use information and communication technologies to find, evaluate, create, and communicate information that requires both cognitive and technical skills. And then computer science, the study of computers and algorithmic processes, including their principles, hardware and software designs, applications, networks, and their impact on society. The committee came up with 5 strands to focus the DLCS standards on, and they're shown here in what's called the Conceptual Framework, this graphic. So you see the little icon of a student there in Alabama, and stretching out are the strands of computing analyst, computational thinker, citizen of a digital culture, innovative designer, and global collaborator. And one thing to notice is that each of those strands is actually a description of the student. We also wanted to plan for the future, so you can see to the left there's an empty strand that is left there because we don't know what the future might hold. There are a couple other little hidden ideas in this graphic. The outline of the state of Alabama is a circuit board to represent hardware, and the background of the continents is binary code to kind of indicate the software aspect of digital literacy and computer science. Now, one of the things that was also brought to the surface during the committee's work was the idea that there are some standards that carried over across all grade levels. We didn't really want to repeat those standards in every single grade, although they were important across all grade levels. So these 6 standards were labeled as recurring standards. And you have the first one comes from the safety, privacy, and security topic, and that's identify, demonstrate, and apply personal safe use of digital devices. And that's certainly something that you would want students to understand in the lower elementary grades, but also throughout middle and high school as well. The same can be said for legal and ethical behavior with the recognize and demonstrate age-appropriate responsible use of digital devices and resources as outlined in school and district rules. We certainly want the students to be using their devices appropriately. The impact of computing, to analyze the potential impact of computing, that is something that can be done across all grade levels. That certainly will be interpreted differently by younger students as opposed to older students, but we want the students to be recognizing this impact throughout their academic career. Systems, to identify and employ appropriate troubleshooting techniques used to solve computing or connectivity issues. We certainly need students to be able to troubleshoot their devices and their connections as much as possible. Collaborative research. This may be one of the more important ones because at all grade levels, students can locate, curate, and evaluate information from digital sources to answer research questions. Now, in the early grades, those questions may be very simple, identifying living or non-living organisms or things when presented with them in an online environment. Digital tools, the production, review, and revision of authentic artifacts using appropriate digital tools. Again, by incorporating appropriate into the standard, that standard can be applicable across all grade levels. So these are the recurring standards. They are present in each grade level, and they are designated with the letter R. So R1, R2, R3, R4, R5, R6 at the beginning of each grade level. Now, as we work our way into the strands, we're going to briefly discuss each of the strands and some possible resources for them. So we'll start with computational thinking. And as computational thinkers, students are able to break problems into their component parts, identify the important pieces of information, and use that information to solve problems. And the subtopics that are included here, abstraction, algorithms, and programming and development. So let's take a moment just to kind of identify how we have the Alabama Digital Literacy and Computer Science standards organized. You have the strands first, so in this example, computational thinkers, and then you have subtopics like abstraction, and then you have the actual standards. So it's kind of a hierarchy, the top of which is the strands, then subtopics, then the actual standards. So for instance, under abstraction, an example of a standard might be remove background details from an everyday process to highlight essential properties. This is a thing that they would be doing. And to demonstrate how this can be done across all grade levels, here's an example just from an English language arts class where you're diagramming sentences, identifying the main idea. You're breaking the idea up into its parts, removing the extra information to get to where you can actually solve the problem. Algorithms, another example. An algorithm is simply a process or set of rules to be followed in calculations or other problem-solving operations, especially when done by a computer. So teachers have been using algorithms for basically forever. We simply weren't wording it in that way. So anytime you have a series of steps or procedures, how to tie your shoe, following a recipe for food, the steps for solving a math problem. Anything like that is, in fact, an algorithm. And one of the ways we can integrate computer science easily across all the grade levels is simply to incorporate this vocabulary when we're talking about any set of rules or processes. Programming and development, the design and building of an executable list that carries out a given task. So these are certainly the basis for computer programs, but not necessarily does it require a computer. So, or writing a program for a computer. You can use a spreadsheet to sort and organize information, a calculator to solve a problem, and there are many examples that could be used here. The second strand is citizens of a digital culture. This is our digital safety. So, as citizens of a digital culture, we want students to be able to discuss the impact of computing in a global society, but doing so safely, securely, ethically, and legally when they interact with digital environments, and also to protect their own digital identities. Understanding that we have a digital identity is one of the first steps of being a citizen of a digital culture. So the subtopic of safety, privacy, and security, I'm not going to read this whole thing to you, but the idea is to make sure students understand that this safety, security, and privacy is both physical and digital. We certainly want students to understand that when, for instance, they're home alone, they need to lock their door. That's part of security. But when they're working in a digital environment, that equivalent to locking the door is utilizing a password and not giving that password away and having a good password. So these are just some examples of how we can incorporate this into the classroom. Legal and ethical behavior, again, this exists both physically and digitally, just like you would teach students not to steal from a convenience store. You also will be teaching them not to steal someone's digital work. And again, this looks different at the lower grades than it does in the upper grades, but it's still important across all grade levels. Digital identity. Students need to understand that they have a digital identity. And while we'll talk about digital identity even in the earliest grades, beginning in grade 4, we really start to look at their digital footprint and digital permanence as an idea. Because even though students are not supposed to have social media accounts until age 13, we know that many do. And just like driving and getting your driver's license when you're 16, we don't wait until they turn 16 and get their license and have a car before we start teaching them how to drive. You do that in advance. So even though students are not supposed to have social media accounts until they're 13, we need to get ahead of that and help students understand how to properly use these to protect themselves and to start building their permanent digital identity well in advance of that. The impact of computing. There are so many ways that computers impact our lives daily. It's just about impossible to think about going through a day without having a digital impact, whether it's the phones that we carry and how that they have the ability to help us by knowing where we are, to geolocate us, to help us find the best route to follow to get to our destination, but also the opposite of that, where the phone can tell where we are pretty much at any time. And understanding that that is possible and how to manage that is important for students to learn. So that's just one example of the impact of computing, how quickly we can communicate, things like that. One of the interesting things that I've seen in the past is how heartbreaking it would have been for a kid in the 70s or 80s to learn that their best friend was moving across the country and how difficult it would be to maintain communication and maintain that friendship. Whereas now with email and texting and social media for our older students, it is so much easier to stay connected to those that are far away. Our military families is another great example. Uh, you know, in the 80s, you may go months without actually hearing from a soldier in the field for their family to hear from them. But nowadays, it can be as simple as connecting, even with video chat, so that they can see them as they continue to serve their country. Global collaborators, it's impossible to think that the students of today are not going to be global collaborators. The world is so much smaller now than it was even when my generation was growing up, in that there is so much interconnectivity between people across the globe. And we need to make sure that our students know how to use digital tools to appropriately communicate and use data to inform and persuade and even entertain with society, both locally and globally. So the subtopics here: creative communications, digital tools, and social interactions. Creative communications, this is working to help students publish artifacts that are public and to seek feedback for the purpose of revision, to be able to communicate effectively in a variety of methods. And many times these are using digital tools. We want them to be proficient users so that they can focus on solving the problem or communicating the message. So early on, technology courses of study focused on the use of digital tools. How do I use this tool? Now we want them to be proficient users, but the focus is more on using those tools to solve a problem or communicate a message. Now, in order to do that, one area that did receive a lot of feedback as to whether it was still necessary was the what's commonly referred to as the typing requirement. And the committee looked at this very carefully, and it was determined that typing is a skill that is required of students so that they can be proficient making the solving of problems and communicating messages easier. So there is a typing requirement in the new courses of study from beginning in first grade through eighth grade. There is no requirement for kindergarten. And the requirement is 5 words per minute per grade level. So in first grade, they should be able to type 5 words per minute. In third grade, 15. In sixth grade, 30, and so on. Social interactions. Again, because students are not gaining access to social media until they're 13, at least when they follow the rules. This begins in grade 5, which is before age 13 for most students. But again, we want to get in front of this. And this topic, the subtopic, looks at things like censorship and bias, distortion, collaboration, being able to see the purpose of social interactions and postings on discussion boards and be able to dissect those to see the true meanings. The next strand is computing analyst, and this is where students use computing systems to manage and interpret data and information. Data and information management is certainly an area that is growing exponentially as we become a more data-driven society, both in our professional and personal lives. And these subtopics include data, the systems used to manage them, and modeling and simulation used to demonstrate and interpret them. So when we look at data, we're talking about the management of data, storage of data, and the protection of it and manipulation. Even things as simple as, where does my data exist? When I'm using my cell phone, is it actually on my phone itself? Do I own it? Is it completely mine? Or is it stored online in the cloud? And if so, who has access to it? And this goes hand in hand with the systems for it. Devices, network, security, and even artificial intelligence, how these systems are working to look at our data and use our data both for our benefit, but also sometimes in detrimental ways. Modeling and simulation, very important concept when you're looking at how students can employ these to solve very complex problems. This often can be incorporated into science lab simulations, things that are either too expensive or too um, dangerous to do can be simulated by computers, and designing those models and simulations is an important skill that students need to understand. Innovative designer. This, of course, is when students are able to look at human and computer partnerships, look at the design process to create useful and thoughtful solutions to problems. So, design thinking and the way humans and computers interact. Human and computer partnerships, these are very simple. This can be when humans co work with AI systems or other machines, rather than using them simply as tools. This is collaboration between man and machine. Sometimes these are using the strengths of one to make up for the weaknesses of others. Um, One of the best examples of a human machine partnership that I can think of is the computer that allowed physicist Stephen Hawking to communicate. Even though he was unable to do so physically, he was still able to interact and remain productive um, really to the end of his life, even though he spent most of that lifetime unable to move using his physical capabilities as anyone else would. Design thinking, this is an important concept throughout science and also in computer science, where it's the iterative process that we use to help look at a problem, identify solutions and strategies, and design a solution to a complex problem. And design thinking is used in just about every area of research and design. And it's that cyclical process that lets students follow a set design process in order to quickly and effectively solve problems in creative ways. Now, for each of these strands, there are a variety of resources that have been provided by the State Department of Education for teachers. One of the first stops is almost always ALEX, the Alabama Learning Exchange, and you can get to that down at alex.state.al.us. This site is so well maintained and popular that if you simply Google the word ALEX, it's almost always the first result. But you can see here in this screenshot that the digital literacy and computer science standards are available, and they are provided in a way that you can easily spot just your grade level, the grade level you're looking for, or the entire document itself. One of the things that has been created by the ALEX team that is extremely helpful is the unpacked standards. Now, unpacking standards, for those that aren't familiar with this term, is where the course of study standards, which can be multifaceted and complex, are broken down into their parts, where you can see especially the evidence of student attainment, teacher vocabulary that needs to be used, knowledge that the students need to have, and skills the students need to have in order to meet that standard. Well, the ALEX team has actually unpacked all of the digital literacy and computer science standards. And what's great is they're built into the ALEX tool now. So when you click on a standard, there is now a separate link for the unpacking, and you can see the unpacking right there in line with the rest of the standards. They have also worked to design a digital literacy and computer science crosswalk, and this is a crosswalk between the new course of study, the DLCS standards of 2018, and the old technology course study standards from 2009. So in this screenshot, you see that the repeating standard, the recurring standard of identify, demonstrate, and apply personal safe use of devices for kindergarten is the equivalent to the old kindergarten 2.4 standard. And this is just a crosswalk so that you can move from the old course of study to the new course of study. There are a number of other resources that are available. The course of study team, the development team for the course of study for digital literacy and computer science, knew that this was going to be a big change for teachers. And so they developed a companion website, and the URL is down there at the bottom. And this is a site that is maintained by two members, led by two members of the course of study committee, and supported by the ALEX team to provide a number of resources. And if you look over on the left side, you see the strands there, as well as a link for the curriculum crosswalks and a glossary link. So that's a very helpful resource if you're looking for resources or ideas on a particular strand or subtopic. All of these materials have been developed in cooperation with the Alabama State Department of Education, AMSTI, the Alabama Math, Science, and Technology Initiative, the ALEX team, the Alabama Technology and Motion Specialist, and the Alabama Leaders in Educational Technology. So this is a cooperative effort to provide these supports, and there are a lot of trainings that are available, and you can learn more and get a copy of this presentation if you go up there to the tinyurl.com/ALETDLCS in all caps. And if you're looking for a computer science workshop for K5 elementary, you can go to bit.ly/CSF request, and in cooperation with A Plus for Education, a free on-site computer science fundamentals workshop can be held at your school, again, free of charge. The A Plus College Ready team provides an instructor, a certified instructor, as well as all of the other resources you will need to do that. So I hope this has provided a nice overview of the digital literacy and computer science standards. It's certainly an introduction, but we invite you to take a look on ALEX for the full digital literacy and computer science standards, and to review your grade level, and especially the companion website to help you implement these effectively. Again, my name is Keith George. You can follow me on Twitter at BigTechCoach, and I'll be happy to answer any questions you might have. Thanks.